Okay, let's look at some of the questions at the end of section 3.5 with the transformations. This is just about taking a point and what's going to give you a new point if you transform it. So let's look at some of the rules. Now remember this, you're going to see a lot of just f of x. In other words, if you take any function and flip it, move it, whatever you need to do, I'm going to use root x as an example, okay? But remember, yours will be just general, take a function and do something to it. So a negative in front of the function, okay, which I'm doing here. Remember, that means flip it over the x-axis. So if I take any point, such as 4, 2, if I flip it over the x-axis, I'll end up with 4, negative 2, okay? I have just changed only the y coordinate, okay? Not the x, because I flipped it over the x-axis. So there you go. Remember, negative inside, okay? So this might have something like this. Maybe it says that in the questions, okay? Negative inside. In other words, take a function, put the negative here. This means, remember, flip it over the y-axis. So again, 4, 2. Now, if I flip it over the y-axis, that means I'm changing the x-coordinate. Only the x will change. Can you see that? So that becomes negative 4, 2. I didn't change the y, I just changed the x. The negative was inside. Okay, let's keep on going. Remember, this is the left-right movement. This is moving to the right 2. Now, that is an x movement. So again, if I take the point 4, 2, okay? If I take the point 4, 2 and move it to the right 2, that's going to give me 6, 2. And there it is, okay? So that is a right movement. It could be a left movement. Remember, you're only changing the x for that one, left and right. Right, here we go. Okay, this one, this is the up and down movement, which means you're going to be changing the y coordinate. Okay, so again, if this is 4, 2, if I go down 2, then 4, 2 becomes 4, 0. I just subtracted 2 only from the y coordinate, and there it is. Okay? Keep on going. Now, these are the harder ones, okay? Now, I think of doing this. Take your good old linear y equals x graph. Okay, y equals x. If I do y equals 2x, then it's steeper, okay? Now then, this means that I must have stretched it vertically, but you could also think of this as compressed it horizontally, okay? So let's think about that. Am I stretching it vertically or compressing it horizontally by this factor of 2? Well, the number in front, that means stretch it vertically, which means you're only going to be changing the y value, okay, if it's a vertical stretching. So here we go, here again, here's good old 4, 2. If I do it by a factor of 4, I'm just going to multiply the y value by 4. In other words, I should get an answer of 4, 8. Let's have a look. Yes, there it is. That's 4, 8. Okay, so remember, number in front, there. So again, you might see this, 4 f of x. That's what you might see on the question, okay? 4 times the function. But also think of it like this. Remember, if you like to think of f of x equals as the same as y equals, then you've just done 4 times y, if you want to think of it as 4 times f of x, okay? And there you go. I multiplied that by 4, okay? So, think about that. Stretching it vertically. Of course, the next one is compressing it horizontally. This is inside the function, so I'm going to shrink it in this direction. So think about it. That direction is the x direction. I'm going to shrink it by a factor of 4. So again, if I have 4, 2, okay, 4, 2, if I shrink it by a factor of 4, I'm going to end up with 1, 2. So in other words, I'm not going that way. No, I'm going this way, and there it is, 1, 2. Okay?